Simply change, create PFAS-free solution. This is the topic for today's presentation. If you think about changes, they are often apprehended as complex and daunting. My name is Tanja Berning, and together with my colleague Thomas Zitzatka, I would like to show you in the next minutes that changes don't have to be overwhelming and deterrent. A change into a PFAS-free future will enhance environmental safety, open doors to new opportunities, and create sustainable and innovative product solutions. Before we have a look into BYK's new additive solutions, a short overview of all products where you will find PFAS in BYK Additives. The well-known BYK 060 defoamer family. Some surface additives. PTFE belongs also to PFAS, so PTFE-based wax additives are also affected, and one processing additive. As a leading innovator, we decided to end the production of additives containing PFAS by end of 2025. We are convinced that we can help phase out products containing PFAS by offering alternatives and showing new ways in the formulation of sustainable solutions for a sunny road into the future. But why are PFAS-based products so often used in coatings? PFAS-containing products have a unique property portfolio for various applications, like strong reduction of surface tension, which leads to superb substrate wetting and spreading properties, as well as anti-crater properties. Furthermore, they are easy to recoat and achieve good leveling properties and, if needed, also anti-fingerprint properties. If we are talking about Fluoro surfactants, they can stabilize the foam, but on the other hand, in case of fluorinated defoamers, they can be a very effective defoamer. Last but not least, by using a PTFE-based wax additives, excellent scratch and abrasion resistance can be achieved, as well as a texture effect. So, leading the change and get insights into BYK's PFAS-free solutions for liquid coatings. Let's start with defoamer. Foam-free and additionally PFAS-free. This is an unmatched excellence. Many of you know the BYK 060 family as excellent defoamers. As PFAS-free product solution, we developed the new BYK 1810 family. So now you can ask, why do we need so many different products? Why cannot one product fit for all? Unfortunately, this is not really realistic when you try to replace PFAS. The BYK 060 family is a product family which is widely used in many different solvent-based and solvent-free systems. That is why we have developed different products to cover all kinds of application areas. Showing excellent deforming properties in one example of general industrial sector. It is a high solid 2-pack PU system where PFAS-containing defoamer are compared with the new BYK 1815 in our standard defoaming test. So, stirring up the paint for 2 minutes at 4 meters per second to incorporate a lot of air and afterwards pour it out onto PE foil. In this case, BYK 1815 is even better than the standard defoamer and can be used as a PFAS-free solution. Moving now to the second additive group, the surface additives. Finding solutions with zero PFAS and at the same time maximum performance. If we talk about Fluoro surfactants, they are used to achieve different properties like good leveling and improved substrate wetting, just to name two of them. PFAS-free perfection for every surface can be achieved by using following product groups. Polysiloxanes, which are important in terms of reduction of surface tension, polyacrylates and silicone-free polymers to improve flow and leveling, silicone surfactants and silicone-free surfactants, especially developed for water-based systems, and the macromer chemistry-based products, which are specialists in increase of surface energy. The right PFAS-free additive solution depends on the application, the silicone tolerance, the system itself, and the desired properties. BYK offers suitable PFAS-free alternatives for all these different requirements. One example can be seen here on the next slide by highlighting BYK 3450 and BYK 3451. Both are super spreader for critical substrates. In this diagram, you can see the influence on spreading behavior at several substrates by adding different additives into water. Without surface additive, water has a high surface tension and not the abilities to spread as it is visible on this picture. Compared to BYK 3451, which achieves a reduction of surface tension and exceptional spreading behavior. Third very important additive group where BYK offers PFAS-free solutions are PTFE-free wax additives for a peerless performance. Also here we developed a new wax additive family, which is the TerraFlower 1050 family. Excellence in every detail. They show excellent results regarding scratch and abrasion resistance and are comparable to our standard PTFE-based products. Additionally, all other products in our current wax additive portfolio are already PTFE-free and can be taken to change in your coating into a new PFAS-free version. One example showing here to highlight the benefits of using TerraFlower 1050 family. They are tested in a water-based one-pack acrylic clear coat formulation of general industrial sector. Focus is on abrasion resistance, where Taber abrasion and Watzau are tested. All three free of PTFE wax additive achieve superb results in Taber and Watzau, which are also better compared to TerraFlower 996R, a standard PE PTFE-based wax additive. Excellent results in abrasion resistance at Watzau test are also visible on the microscope pictures. TerraFlower 1051 and TerraFlower 1052 resist to over 300 centimeters, so no substrate is visible. Additionally, what you also can see on the microscope picture is that the new wax additive family provides a perfect wax distribution. So an excellence in every detail. Leading the change and get insights into BYK's PFAS-free solutions, this time for powder coatings, where I would like to hand over to my colleague Thomas.
Thank you, Tanja. Now I will take the part of powder coatings. Within the next couple of minutes, I'd like to show you our current recommendations to create PFAS-free formulations. The use of PFAS-containing additives in powder coatings is not dependent on specific formulations or resin systems. It goes across all various systems and colors and is mainly related to PTFE. The key properties are fine texture effect with various gloss levels, improved scratch resistance to protect the surface, and improved abrasion resistance. Let's start with texture effects. A typical micronized PTFE additive creates a fine texture effect at low gloss levels. As shown by the picture, a low dosage of only 0.5% provides this nice homogeneous surface. We made our trials in the hybrid formulation, which is our test system in our laboratory. The smooth control panel on the left doesn't contain any PTFE. The third picture shows the effect of 5% Garamite 1210, and clearly visible, the texture is certainly too coarse and gloss too high. Doesn't fit exactly, therefore we did another trial. Here we used 4% Clayton HY. This goes in the other direction, very fine texture effect and even too low gloss levels. Therefore, not surprisingly, we decided to combine both as a 50-50 mixture. This combination provided the best match by optical appearance and gloss level. But this is now the best answer for all cases? No, certainly there is more individual adjustment necessary. This example is based on a customer formulation, with the target to match the current PTFE-based standard. As first trial, we used here the 50-50 combination Clayton and Garamite again, but surprisingly, in this case, optical appearance didn't fit to standard, as well as the measurement values didn't fit at all. The graph shown in the measured values of the Spectro 2 profiler instrument, as you can see this device here on the picture. The green pictures showing the surface topography generated by the instrument's software. By the support of the instrument measurement results, we made some further modifications of the formulation. We changed the dosage and we used Ceraflower 950 as another wax additive in this formulation. And with the third trial, we were able to match the standard nearly perfectly, in optical appearance and in measured values. Let's move over to scratch resistance. There are several test methods available. This is only one example. In this so-called hammer test, we scratch two panels with the same coating formulation to each other. Afterwards, the surface is evaluated regarding scratch marks and gloss levels. As you can see on the control panel, there are a lot of scratches visible. The second panel with the current PTFE-containing standard additive provides surface protection by the lubricating wax layer. But as a negative side effect, the wax causes also a lower gloss level. BYK 3932P improves the surface protection by lowering COF, coefficient of friction, high surface slip. This results in good scratch resistance, and in addition, we don't see any gloss reduction. The fourth panel now shows our Ceraflower 1051, which provides a comparable performance as the PTFE standard. To give you an impression of our further developments, I've included the last pictures with one of our R&D samples. This shows overall the best results. High gloss, high surface slip, no scratch marks. You can imagine now there is something good in our pipeline. And now abrasion resistance. Tested with the standard Tabor abrasure. The lower the loss of weight, the better the abrasion resistance. Important note, as you can see on the second bar, BYK 3932P is good for scratch resistance, but will not work for abrasion resistance. Our standard PTFE-based standard additive shows good improvements. Ceraflower 1051 works well too, but we can do even better. With the included another R&D samples here on the graph, you see that there is also better result. We are very optimistic that these PTFE-free additives will perform much better than the current market standard. Abrasion resistance is improved by more than 50%. Same as before when we talked about scratch resistance. This is ongoing in our R&D pipeline. Let me now summarize our current recommendations. For PTFE-free texture effects, we have a wide range of possibilities with our Clayton and Garamite family. Based on our experience, we can give you further individual guidance to modify your formulations even better. For example, by different combinations or using other wax additives. In case of scratch resistance, BYK 3932P is our first recommendation, followed by Ceraflower 1051. Ceraflower 1051 can also be used for abrasion resistance. In all three cases, please be aware that we are actively working on further developments. Therefore, don't hesitate to contact us for further details. BYK leads the way to a PFAS-free future. We hope that we can help you on this way. It can be a simple change. Thank you for your attention.